Vertical farming is an innovative approach to agriculture that involves growing crops in vertically stacked layers. This method addresses the challenges of limited land availability and the impacts of climate change that traditional farming faces. Vertical farms can be built in urban areas, making fresh produce more accessible to populations. The controlled environment of vertical farms allows for optimized growing conditions, leading to higher yields and reduced resource use. Vertical farming utilizes advanced technologies like LED lighting, hydroponics, and automation to maximize efficiency and sustainability. This revolutionary farming technique has the potential to transform the future of food production and distribution. Vertical farming is a revolutionary agricultural technique that involves growing crops in vertically stacked layers, often in controlled indoor environments. By cultivating plants vertically, vertical farms can optimize limited urban or rural land, producing higher yields in a smaller footprint. Vertical farms utilize advanced technologies like hydroponics, LED lighting, and climate control systems to create an optimal growing environment for the crops. This sustainable approach aims to address global challenges like food security, water scarcity, and environmental impact through innovative, resource-efficient agricultural practices. Vertical farming represents a promising solution to some of the world's most pressing agricultural and environmental concerns. Traditional farming methods are struggling to keep up with growing global food demand due to limited arable land and weather-dependent crop yields. Conventional agriculture has a significant environmental impact, contributing to greenhouse gas emissions, soil degradation, and water scarcity through excessive use of land, fertilizers, and pesticides. Farmers face numerous unpredictable challenges such as drought, pests, diseases, and fluctuating market prices, making it difficult to ensure consistent and reliable food production. The farming industry often struggles to attract and retain skilled workers, leading to labor shortages that can hinder productivity and efficiency. Vertical farming is the practice of growing crops in vertically stacked layers, often in controlled indoor environments like warehouses or repurposed buildings. By growing crops vertically, vertical farming allows for efficient use of limited land area, particularly in urban settings where space is at a premium. Vertical farms utilize advanced technologies like hydroponics, aeroponics, and LED lighting to precisely control the growing environment and optimize plant growth. Vertical farming aims to reduce the environmental impact of traditional agriculture by minimizing water usage, eliminating the need for pesticides, and reducing transportation costs. The vertical farm you see in the image represents the future of agriculture. It's a highly efficient, high-yield way to grow crops year-round, regardless of seasons or weather. Vertical farms can produce up to 100 times more food per square foot compared to traditional outdoor farming. This is because they maximize space by stacking growing levels vertically. With controlled indoor environments, vertical farms can grow crops 365 days a year, without being impacted by seasonal changes or extreme weather. Vertical farming uses up to 95% less water than traditional agriculture by recirculating and efficiently managing water resources. This makes it a much more sustainable approach. The small footprint of vertical farms means they require far less land compared to traditional outdoor farms, making them ideal for urban and space-constrained areas. Vertical farming can dramatically increase crop yields compared to traditional outdoor farming. By stacking multiple growing layers vertically, vertical farms maximize limited land area. Vertical farms precisely control growing conditions to optimize plant growth and productivity. Conventional farming yields 10 to 15 tons per acre, while vertical farming can yield 50 to 100 tons per acre. The controlled environment of vertical farms allows for year-round production, rapid growth cycles, and elimination of weather-related losses. These factors lead to crop yields up to 10 times higher than traditional agriculture. Vertical farming uses up to 95% less water than traditional farming. This is achieved through advanced irrigation systems and closed-loop water recycling. The bar chart clearly illustrates the dramatic difference in water consumption between conventional and vertical farming. Conventional farming has much higher water usage, around $10,000, while vertical farming only requires about $500 worth of water. This massive reduction in water usage is a key benefit of vertical farming and makes it a much more sustainable agricultural approach. Vertical farming allows us to create a highly controlled, pesticide-free environment for growing crops. This leads to a dramatic 95% reduction in the need for pesticides compared to traditional farming. We're able to eliminate over 1,000 different organic compounds found in chemical pesticides. Pesticide residues on the crops are limited to less than 0.1%, which is incredibly low. All of this results in an estimated $10 billion in annual savings from reduced health and environmental costs associated with pesticide use. The ability to grow food with virtually no pesticides is a major benefit of vertical farming and a key part of our sustainable agriculture approach. Vertical farming allows us to create a highly controlled, pesticide-free environment for growing crops. This leads to a dramatic 95% reduction in the need for pesticides compared to traditional farming. We're able to eliminate over 1,000 different organic compounds found in chemical pesticides. Pesticide residues on the crops are limited to less than 0.1%, which is incredibly low. All of this results in an estimated $10 billion in annual savings from reduced health and environmental costs associated with pesticide use. The ability to grow food with virtually no pesticides is a major benefit of vertical farming and a key part of our sustainable agriculture approach. Vertical farming is an innovative approach that allows us to grow crops efficiently in a compact, controlled environment. By stacking crops vertically, we can maximize the use of limited space and dramatically increase yields per square foot. A range of cutting-edge technologies are used in vertical farming, from specialized lighting and climate control systems to automated irrigation and nutrient delivery. These technologies enable us to precisely monitor and optimize growing conditions, leading to higher productivity, reduced resource consumption, and more sustainable food production. The image on this slide shows a modern vertical farming setup with clean, efficient equipment and lighting designed to support optimal plant growth. Hydroponics is a method of growing plants without soil, using nutrient-rich water instead. The key benefits are: nutrient-rich water delivers essential nutrients directly to plant roots, allowing for rapid growth and higher yields. Growers can precisely control the nutrient composition, pH, and other factors to optimize growth for a wide range of crops. Hydroponic systems can be stacked vertically, allowing for high-density, space-saving cultivation in urban or controlled environments. This makes hydroponics a highly efficient and productive way to grow a variety of crops, especially in areas with limited land or soil resources. Aeroponics is a highly efficient indoor farming system that uses a fine mist to deliver nutrients directly to the plant's roots suspended in the air. The exposed roots allow for more efficient absorption of water and nutrients, leading to up to 30% faster growth compared to traditional soil-based methods. This vertically stacked, high-tech system utilizes LED lighting and a mist system to create an optimized growing environment for the plants. Aeroponics is a promising technology that can help address challenges in food production and sustainability. Aquaponics is an integrated ecosystem that combines aquaculture, raising fish, and hydroponics, growing plants in water, into a symbiotic, closed-loop system. The fish waste provides natural fertilizer for the plants, while the plants help filter the water for the fish, creating a nutrient-rich environment. Aquaponics recirculates and reuses water, reducing water consumption by up to 90% compared to traditional farming methods, making it a highly water-efficient approach. Aquaponic systems can be designed for small-scale home use or large-scale commercial production, making it an accessible and versatile solution for a wide range of growers. LED lights are a highly energy-efficient lighting solution for vertical farming operations, consuming significantly less power than traditional lighting options. The ability to fine-tune the light spectrum emitted by LED lights allows us to optimize the wavelengths that are most beneficial for plant growth and development. LED bulbs have an exceptionally long lifespan, often lasting much longer than traditional lighting, which reduces maintenance costs and downtime for the vertical farming system. The precise control offered by LED lighting enables us to program the intensity, duration, and timing of light exposure to create the ideal conditions for our plants. Precision climate control is essential for consistent growing conditions across a wide range of crops. Our sophisticated systems maintain optimal temperatures to create the perfect environment for plant growth. Precise humidity regulation prevents issues like mold and ensures plants receive the right amount of moisture. Programmable LED lighting replicates natural light patterns, optimizing growth and productivity. These customized climate control solutions allow us to create the ideal conditions for healthy, thriving plants. Vertical farming leverages advanced automation to streamline operations and boost efficiency. Automated systems handle labor-intensive tasks like seedling transplanting, harvesting, and packaging. Robotic arms and autonomous vehicles can take on heavy lifting, precise plant monitoring, and repetitive tasks. This frees up human workers to focus on more complex and strategic activities. Sensors and computer vision constantly monitor plant health, environmental conditions, and resource usage. Real-time adjustments can be made to optimize growth based on this intelligent monitoring. Data analytics and machine learning identify opportunities to improve yields, efficiency, and overall productivity. This data-driven approach drives continuous optimization of the vertical farming operation. Vertical farming is a rapidly growing industry with diverse business models to suit different market needs and scales. From small urban rooftop farms to large-scale indoor facilities, there is a wide range of entrepreneurial opportunities in this space. The flexibility and scalability of vertical farming makes it appealing for entrepreneurs and investors. Vertical farming can be applied in urban, suburban, and even rural settings to bring food production closer to consumers. As the technology and economics of vertical farming continue to improve, we'll likely see even more innovative business models emerge. Urban rooftop farms transform underutilized rooftop spaces into productive agricultural sites, optimizing limited land in dense cities. Locating farms within cities reduces the distance between food production and consumption, improving supply chain efficiency and freshness. Many rooftop farms use sustainable techniques like hydroponics and renewable energy, promoting eco-friendly urban food production. Rooftop farms can serve as educational and recreational spaces, fostering community engagement with local food systems. Indoor vertical farms provide a completely controlled growing environment, allowing for precise control over temperature, humidity, lighting, and nutrient delivery. By growing crops vertically, indoor farms can maximize the use of limited space, especially in urban areas with high land costs. Indoor vertical farms use up to 95% less water and 99% less land compared to traditional outdoor farming, making them highly resource efficient. This allows for year-round production and higher yields in a small footprint. The controlled environment also enables the use of sustainable farming practices and reduces the need for pesticides. Warehouses present a great opportunity for vertical farming operations, as they offer expansive interiors and sturdy infrastructure that can be repurposed. Precise control over lighting, temperature, humidity, and other environmental factors in a warehouse setting enables optimal growing conditions for plants year-round. Locating vertical farms in urban areas or near distribution hubs can reduce transportation costs and the carbon footprint associated with traditional agriculture. Efficient stacking of growing racks in a warehouse setting maximizes the utilization of limited floor space, allowing for high-density, large-scale vertical farming operations. Community-based vertical farms are a powerful way to engage and empower local neighborhoods. These farms foster a sense of ownership and involvement among residents who can participate in the growing process. They also serve as living classrooms, providing hands-on learning about sustainable agriculture, nutrition, and environmental stewardship. By addressing food deserts and increasing access to healthy foods, these farms drive positive social change and improve community well-being. Decentralized, community-driven vertical farms help build more resilient and self-sufficient local food systems, reducing reliance on distant and vulnerable supply chains. Vertical farming offers a sustainable solution to meet growing global food demands. Key challenges to scaling vertical farming include automation, energy efficiency, logistics, and scalability. Automation through advanced robotics and AI can streamline operations and improve efficiency. Optimizing lighting, climate control, and resource use will be critical for improving energy efficiency. Developing efficient distribution and supply chain processes is essential for logistics designing. Modular, expandable systems will allow vertical farming operations to scale up to meet demand. Vertical farming offers significant potential to improve sustainability and efficiency in agriculture, but it also comes with unique operational challenges. We'll explore 3 key areas where innovative solutions can help overcome these challenges and unlock the full benefits of vertical farming. First, optimizing energy efficiency is critical. By implementing renewable energy sources, upgrading HVAC systems, and leveraging smart technology, we can dramatically reduce energy consumption. Next, automating key processes like seeding, harvesting, and packaging using robotics and AI can boost productivity and consistency. Finally, supply chain optimization through streamlined logistics, distribution, and transportation is essential to ensure timely delivery while minimizing waste and carbon footprint. Addressing these operational hurdles will be crucial to realizing the promise of vertical farming and making it a viable, sustainable solution for the future of agriculture. Vertical farming operations can significantly reduce energy consumption by implementing energy-efficient LED lighting systems. LED lighting maintains optimal growing conditions while being much more efficient than traditional lighting. Integrating renewable energy sources like solar panels can help power vertical farms and offset their energy demands, improving overall sustainability. Advanced control systems and data analytics can optimize energy usage by monitoring and adjusting lighting, temperature, and other environmental factors in real time. Smart monitoring allows for precise optimization of energy use to support plant growth while minimizing waste. Vertical farming operations require efficient logistics to transport produce from farm to market. Optimizing transportation routes and modes can minimize costs and environmental impact. Careful monitoring of crop yields and real-time demand data enables vertical farms to plan production and avoid waste. Automated inventory management systems can optimize inventory levels. Vertical farms can use compostable or recyclable packaging to reduce waste. Innovative packaging solutions preserve freshness and protect produce during transit. Connected systems allow vertical farms to track products from seed to shelf, providing transparency and enabling rapid response to any issues. Vertical farming is a sustainable approach to food production that aims to minimize environmental impact. Key sustainability features include use of renewable energy, like solar panels, hydroponic systems that recycle and reuse water, LED lighting for energy efficiency. These practices create a more resource-efficient and environmentally friendly food production model. Vertical farming aligns with circular economy principles, reducing waste and maximizing the use of resources. This slide provides an overview of how vertical farming prioritizes sustainability and environmental impact. The circular economy is a regenerative system that aims to eliminate waste and continuously reuse resources. It keeps products and materials in circulation through a closed-loop cycle. The 5R principles are the key tenets of the circular economy. Reduce consumption and waste. Reuse products and components. Recycle materials back into the production cycle. Repair and maintain products. Renew and regenerate natural systems. Transitioning to a circular economy requires collaboration between businesses, governments, and consumers to design out waste and keep resources in use. The image on this slide depicts a sustainable vertical farm, showcasing renewable energy sources like solar panels and wind turbines, surrounded by lush greenery. The key focus of this slide is on reducing the carbon footprint through various strategies, including energy efficiency, waste management, transportation optimization, and sustainable practices. Energy efficiency can be achieved by implementing renewable energy sources and reducing reliance on fossil fuels. Comprehensive waste recycling and repurposing programs can help minimize greenhouse gas emissions. Adopting eco-friendly transportation methods, such as electric vehicles and efficient logistics, can significantly reduce carbon emissions. Promoting sustainable practices throughout the entire supply chain is crucial to minimizing the overall environmental impact. Waste management and recycling are crucial for creating a more sustainable future. Implementing circular economy principles is key. We need to reuse and recycle waste materials to minimize environmental impact. Investing in robust recycling facilities and collection systems is essential for efficiently processing and repurposing waste. Transforming organic waste into compost or biofuel creates a sustainable cycle of resource recovery. Educating and empowering employees to adopt sustainable waste management practices fosters a culture of environmental stewardship. Vertical farming is an innovative agricultural approach that leverages technology and limited space to grow crops efficiently and sustainably. Advancements in areas like automation, renewable energy, and precision farming are enabling vertical farms to overcome historical operational challenges. These technological breakthroughs are driving the increased adoption of vertical farming as a viable solution to meet growing global food demands in a more environmentally friendly way. The image on this slide depicts a futuristic vertical farm that showcases some of these cutting-edge technologies and capabilities. I'll dive deeper into specific innovations and the benefits of vertical farming in the upcoming slides. Vertical farming is an exciting new field that leverages advanced technology to grow crops more efficiently and sustainably. AI-powered optimization algorithms help vertical farms precisely control and fine-tune every aspect of the growing process, from nutrient levels to lighting, to maximize crop yields. Automated robotic systems handle the repetitive, labor-intensive tasks like planting, harvesting, and distribution, freeing up human workers to focus on higher-level management and monitoring. Sophisticated sensor networks continuously monitor environmental conditions, allowing farmers to make real-time adjustments to keep plants healthy and thriving. These technological breakthroughs are transforming the future of agriculture, making vertical farming a promising solution to feed growing populations while reducing the environmental impact. Vertical farming is becoming more widespread as the technology becomes more advanced and cost-effective. Cities, communities, and businesses are increasingly adopting vertical farming to reimagine local food production. Vertical farming has the potential to address global food insecurity by establishing farms in non-traditional agricultural regions like urban areas and deserts. New business models are emerging, such as urban farming cooperatives, commercial partnerships, and community-supported agriculture, which are driving the growth and accessibility of vertical farming. These innovative models are making vertical farming more accessible and viable for a wider range of communities and organizations. Vertical farming offers a promising solution to address global food security challenges. It enables sustainable, high-yield agriculture in urban and space-constrained areas, reducing strain on traditional farming. Vertical farms can improve access to fresh, affordable produce, especially in food deserts and developing regions with limited arable land. Vertical farming's smaller ecological footprint and reduced resource usage can help mitigate the environmental impact of conventional agriculture. As vertical farming technologies continue to evolve, they provide innovative solutions to boost global food production through higher yields, year-round growing, and more efficient resource management. Vertical farming is an innovative solution that harnesses technology to transform the future of agriculture. Vertical farming can help address global food security and environmental challenges through sustainable practices. The flexibility and scalability of vertical farming make it a promising strategy for the future of food production. This slide highlights the key takeaways from the presentation, emphasizing how vertical farming is driving progress, contributing to global sustainability, and offering a scalable and adaptable approach to food production. As the speaker, I would emphasize the transformative potential of vertical farming and how it can help us address critical challenges in agriculture and food security in a sustainable way.